Okay, so I think if we get to review inheritance, so if you're working on on your project, that's just continue working on it. If you need this review, then you can tune in to what I'm saying. Anytime anyone has any questions, whether it's about this or a program, just go ahead and interject and ask your question, even if it's about your project. If you need the answer for your project right now, then just go ahead and interject, and that's fine. But I figured that rather than me just sitting here, I could go ahead and review the inheritance stuff a little bit. So, can people hear me?
Yep.
So, I have this little main program here. I'll get rid of this whole world. And so the first kind of inheritance that we went over was basically just regular inheritance. So I add a class, and you don't have to follow along with this. It might be I have this recorded, and it might be more useful just to kind of have a chance to kind of look at what I'm doing. Let's see. We used employee already. Maybe I'll just it's a good example. Animal. Oh no, I won't do that one. Inventory. And let's say we're making we're going to make an inventory of things in my metal shop. So I've got inventory item, and I make this base inventory item, and I say, well, if I'm an inventory item, I probably have an ID field. Maybe there's a number of these things. A name for it. A little more detailed description. Serial number. Part number. A manufacturer. So I've got this generic inventory item class. And then if I was going to make an inventory, on the other hand, maybe I give it an ID field too, but I also give it maybe some kind of description, and I'm going to make a list of inventory items. And I'm going to call it items. So you kind of see this pattern a lot, actually, where you have a class for an item, and then you have another class that has a list of items. And we'll expand on that later, but for now, we'll just do that. And then on our program, we'll instantiate a list of, actually, we just need to instantiate an inventory. And then we're going to do a do while loop. And inside this loop, I'm going to instantiate a inventory item. And then I'm going to get all the information for it. So item.id will equal, and I'm going to make a function called getInt from user. Or actually, I think I'll just do it this way. Say int.parse get string from user. Now, this is a function I need to write. So I'm going to do this the tricky way and just let Visual Studio write it for me. Do some weird things here. This could be you made a span of t out of a string. I'm going to make it be a string.
Can I ask a weird question?
Sure.
That has nothing to do with this.
Sure.
So I've decided to use images for buttons.
Yes.
How do I rig that up? Because it's not giving me an image or a click event. It's just weird.
You might have to make a button and then make the image be the content aspect of the button.
Oh, that might be a good idea. I hadn't thought of that. Thanks.
Sure. So I'm just making my input function. This is kind of boring stuff right now. So this will put out the prompt and then ask the user for input, returns it as a string. I just like to, since I have to do two things here, I like to throw that into a little helper function just so that I can put it into one line here, which allows me to then get my other information a little easier. So static and not static. So the reason why we notice in this function it's static, but whereas in inventory, we're not using the static keyword, is because main is a static function, which means that main, there can only ever be one instance of main being called at one time. Within the program class, main is always made static because we kind of just want one main function. And that means that anything that main calls has to be static if we're not instantiating it. So in the case of class, when we instantiate things, we can have multiple elements per class. With static, whatever is declared as static, whether it's a method or a field, there is only one instance of that thing for the entire class. No, we can actually make static elements of we can actually make static elements of a class. So, for example, with our inventory, I could declare maybe public static int, maybe that's make it a property since we're doing it this way. So maybe we have an int, or maybe I'll do a double. And let's say that we have something that's constant across the whole inventory, that the type of shells we have always have the same max weight. If I made this property, then no matter how where I call this, max weight cells will always return 1,000. There'll always be one instance of this. So the reason why you know there's going to be one instance of this is if I was going to reference that, I would actually call it off of. So if I look at, for example, item, I put item dot. You will notice that there is no max shelf size in here. It's not part of item, the instance. And realize I can have multiple items get created. You know, as I go through this loop, there'll be multiple items. So each time I'm doing this, I'm instantiating a separate object. This is why we call this the instantiation statement, because what we're doing is we're instantiating a separate object. However, if I look at inventory item, the class, and put a dot, I look at the inventory class. So I got to do this a different way to explain it. I was looking at the wrong class. So if I look at inventory and I put a dot, you'll notice the inventory doesn't have this max shelf weight. But if I put inventory, the class, and put a dot, we can see that max weight shells is visible. So what static means is that this object which I've declared as static exists, only one instance of this exists, and it exists with relative to the class as a whole. If I were to do this, so that works. Let's say I just wanted to display this for some reason. I would see that this exists only one for this entire class. All the class has the same shelf. On the other hand, maybe I want this actually to be different by each instance. If that's the case, I get rid of static. And if I look at this, now I can't call it off of the class, but I can call it off of the instance. And with that, then it would make sense to then have a set, because now this is going to vary by whichever object it has been created. So this no longer works, and now this becomes something that could be maybe input. Does that make sense? No, this is, so this is, in this case, this is not a static, this is not static now. Notice we've got rid of the static keyword. If I put static, and then I would have to also make my field static. If I make this static and the property static, now this no longer becomes available, and it has to be made accessible this way. Actually, I'll do it like this. Now I'm calling off of the class, not the lowercase field. And that means the max weight of shells will only exist one, or across all objects, they will always have the same because there's only one instance because you're calling out the class. Does that make sense? So the reason why you might make a property static is because, let's say that my shells are all the same throughout all my complexes. So they're always going to be the same. Then, and they all have the same max weight. Then that's why it would be that way. On the other hand, let's say that, you know, each of these inventories is associated with a separate building or a separate room, and the max weight for the shells is different by each room. In that case, then I'd want it to be an instance method and not be static. Does that make sense? And we can use that for, you know, there's creative reasons why we might do that. There's sometimes why you might do that is, you know, like a common reason to make methods static is just because you're making a library of utility functions. Math functions are almost always static because, you know, they're not storing any state or anything. They're just this function, you pass some values and it returns an answer. So we don't need to create an instance of a math class and then use, you know, separate individual methods to do it. So we declare them as static, and they're just utility classes. They're just utility functions that just get used. When we are doing instance things, which most of our classes are going to really be done so that everything is an instance method, we're kind of doing that because we want to make a large collection of objects that are all different but have the same categories of things we want to keep track of. And so in that instance, then we normally make instance methods. And that just means we get rid of we don't use a static keyword, and now this is an instance method, and then we call it off of the object. And that means that since we can make multiple objects, each one will be different. Now, let's see. So I'm going to continue on making my inventory. And now I've got this object, this item. And I'm going to add it to my collection. So first off, I'm going to look at my inventory. I'm going to instantiate it here in the So I'm putting an instantiation here just so that it gets initialized. And you can do that with a property. You can initialize it by just putting an equal after property and put its starting value. That's why I don't have to use a constructor to build it. And so now in here, I'm going to, once I create it, I'm going to say inventory, which is the inventory that I created up above. Items, add this item I created. So you're going to see actually a lot of times we use items and item a lot. Items is usually a collection, and then we have an item that we create, and then we just add it to our collection. And then while get string from user to another. So how about I do another built in here? So I should be able to loop through. Right now we're not doing anything with super tricky. There's no inheritance involved in this. We just have a inventory item class, and so it starts off by asking actually, so I'll say 4,000 pounds and the ID, and then I start adding items. Oh, got a format exception. That's okay. You get the idea though. It's going to loop through, and I can keep adding items to my show. So that's not unusual for the stuff we've done. Having an item, single item that we're adding to a collection, which is inside of another class. Does that make sense? So this is just something for us to start. So now what we're going to do is let's do just a straight up inheritance. So I'm going to inherit from inventory item. And then I'm going to do that by adding another class. And let's say that this inventory item comes as a package. And so there's multiple items inside of that one package. And so the difference is, and so what symbol do I use to inherit? Yeah, I put a colon, and then I'm going to inherit from inventory item. And so basically, that means inventory package has all these things, but the thing I'm going to add is an int for number per package. So let's say that, here we might have, in our inventory, maybe, we're in a store or something, and you have, let's say it's a home store of some sort. So you might have pieces of furniture that are there, like chairs, tables, things like that. But then you have something like a box of bulbs, for example, and there's 6 bulbs per package. And so you're going to say that that's one item is an inventory item, but you want to know how many things there are inside of that one package. So we use this number per package, and the way we're going to implement that is we're just going to inherit from this inventory item class, and then we're going to add this one element. And that will make our our inventory item we'll have another type of inventory item. So what we could do then is we can add either type of inventory item on there. And so what we now have to do is ask the user what kind of item they want. So we're going to say string type item is equal to so we're going to ask them, is it an individual item or a package? And then we're going to say if type item equals I, then we're going to do this. Although what we're going to do is we're actually going to do the declaration before we get into here. We're going to declare an inventory item. We're not going to instantiate it yet. And we're going to say, hey, if they said I, they want an individual inventory item, so we're just going to do a regular inventory item. Else, we're going to say item equals new inventory item package. So we ask the user which one they want, and now notice that here we have the same item. This item is an inventory item, but in one instance I'm creating a new inventory item and setting item. The next one I'm creating a inventory item package and create it. Question, do I have to do anything to change any of these to make this work so far? Does this code that I've highlighted have to change? Well, they're both being instantiated and they're both being placed inside of this variable called item, and item is an inventory item. Yes. Question is inventory item package also an inventory item? You can read this colon as basically also saying not only inherits from, but is a. Inventory package, item package is an inventory item. And here I made a variable that is of type inventory item, and I can, of course, put an inventory item here, but I can also put anything that inherits from inventory item into here. This is polymorphism. So if you're nebulous about that term, that's usually the hard thing to understand. Because these both inherit from the same class, and because this variable is of that class, we can put either one of these in here. Not only that, but does inventory item package have an ID field? And the answer is yes, because inventory item has an ID field, and inventory item package inherits from inventory item. Does that make sense? So if you can understand that, and you may have to run that through your mind a number of times if it doesn't quite make sense. And these are sometimes concepts where it's like, okay, that makes sense, and then you go away from it, and then, okay, I don't quite remember how that works, and then you've got to go back to it. These are kind of hard concepts to understand. But what can help you is the is a and has a concepts of this. Inventory item package is an inventory item. Inventory items have int number, name, description, serial number, part number, and manufacturer. Therefore, even if I instantiate an inventory item and set it into item, then ID name, this item will, all these parts, these properties will exist for item. Good point. Watch what happens here. Even though I say I've assigned you inventory item package into item, can I say item dot number for package equals get string user number for package? And I need to parse that as an int. Why am I getting an error now over number per package in item? Yeah, because item was declared up here as an inventory item, while I can assign an inventory item package into item, item doesn't have a direct reference to number per package. So I can actually do that really up here. Still gives me an error. So how can I deal with this? Well, there's a couple. First of all, does everyone understand why this gives me an error? Yeah. So what I may need to do is do it like this. I use a temporary variable to store this in. So I'll make package item, which is this inventory item package. I'll then get the number for package from the user and put that into package item. And then what I will do is I will say item equals package item. And then I can get the rest with the standard code that I have here. It has everything that's common for all of the other items. So I create this variable. I set the number of package. I make it this temporary one as a package item. I put the number of package in here after getting it from the user. And then I take that, once I have that loaded, I know I'm going to get the rest from this code down here. So I'll just set it into, I'll set this reference into item. Now item, it was defined up here as an inventory item, is pointing to this package item, because package item is inventory item, it can go through and get the rest of these questions filled out. Does that make sense? Now, one thing that might help you understand this a little better is realize that all these are really just pointers. So I want to go through the memory, what happens in memory. In this instantiation, so first off, we declare a variable called item, which is an inventory item. At this point, the compiler knows that I need to refer to something as item, but it really doesn't do anything at this point in time. When we declare a variable, that's really an instruction to the compiler. It says, okay, we're probably going to be doing some stuff with some memory. I need a name. It has a symbols table. Like it says, okay, let's put item on there, but it doesn't have any memory yet. When I instantiate with a new statement, that's what actually creates a place in memory for me to store things. And then item now is a pointer that points to that location. So the item has a memory address and is pointing to that memory location. And then we would go on and you fill up each of these elements, and each of these elements are stored contiguously in memory after the start of where item is in memory. So each of these, if you really look at their pointers, you'd probably find that they're maybe 4 or 8 bytes off of each other as they get stored in different parts of memory. Now, down here, again, I'm going to go back through this. I declare a variable called item, not pointing to anything yet. Here, I also declare a variable called package item. And then I do this instantiation statement. So now package item is pointing to some place in memory. And it's got enough space to store an inventory item package, which means it's got all the space to store an inventory item because we inherited from it, but also it's got a little extra space to store this int, which is, a 4-byte number for the number for package. So it's a little bit larger than what would have been created with this instantiation statement. So this package item is now pointing to that place in memory with all that memory stored. And then here, I take package item and I set the number of package to some value. I get it from the user and I put that into that memory location it was reserved for it. It's kind of at the end. But that gets changed. Then down here, realize, what was package item again? Is it an actual value or is it something else? It's a pointer, right? So package item is pointing to this place in memory, which is storing really just a bunch of default values for this right now and this value. So package item is just that pointer. When I set item equal to package item, all I'm doing is I'm making this point to the same thing a package item is. So both of these are now pointing to this spot in memory, which has all of this package item information. So I'm just handing off the pointer. Now if I say pointer.id, that place in memory that we put to the number for package, earlier up we have the ID field, so then all these get filled in by this code, and it fills in the rest of them. So if you understand these are pointers, it's not quite as mysterious when you realize that this one, we just hand off the pointer to item, and because package item is an inventory item, we can be confident that, yeah, I can assign this pointer to item because both package item and item, and inventory items have IDs. They both have names, descriptions, serial numbers, or part numbers, and because they are both inventory items. They both inherit from it. Watch what happens if I break the inheritance. If I get rid of that and save it, it won't let me do that assignment because now it says, hey, that's not a item is an inventory item, package item is something completely different now because I don't have this inheritance. I put that back in and save it, and it's okay with that assignment statement. Does that clarify some things? So this is one of the reasons why I'm really glad that this school, Von Barbara Johnston set up this program so that you all learn C++ first. Those pointers make this a lot easier to understand. Otherwise, we have to describe it in very nebulous, hand-wavy terms. And it's okay to understand it that way, and it's okay, and, you know, practical purposes, that's how you're going to be kind of understanding you're going to be understanding inheritance and polymorphism is you're going to kind of understand them, you know, just generically. And then when you're working with it, you just kind of develop your process and you just kind of use them. But if you understand that how the pointers are working and how that these things are pointers, it makes it can make it a little easier. And you know, a lot of concepts in programming, you kind of, you go through, you do the process, you kind of sort of understand it nebulously, you get the program done, you move on, and if you survived, and then sometimes you've got to go back and kind of review some of those things, and you keep refining your understanding of things. I keep, even in these areas on inheritance and polymorphism and how pointers work, I keep refining my knowledge on that. I can find new things out that I didn't think about or that I didn't understand. That increases my understanding, but it wasn't super critical for me getting the job done. But it makes me a better programmer as we hammer out those details in a little bit more detail. Okay. Let's see. Got a few more minutes. I'm going to go on to abstract. So one of the things we can do is, let's say that if we looked at our inventory item, let's say that was a good. Here we are, and somebody say, you know what? Not everything has a part number and a manufacturer number. And so what I want to do is I want to have a base class which has ID, number, name, and description. But serial number, part number, and manufacturer, I want that to be split off. So what I'm going to do is I'm going to create another class. And I'm going to call it inventory item base. And in this inventory item, I'm going to take these things. which are going to be common to everything, and I'm going to move them to inventory item base. And inventory item now is going, I'm going to make that inherit from inventory item base. And so, but I'm going to say also, you know what, if I have ID number, name, and description, that's not enough. I need to inherit, I don't want to put that kind of thing in inventory. So what I'm going to do is I'm going to make this class abstract. So you cannot instantiate this. And then over here, I'm going to look at this inventory. And rather than making my inventory, into my inventory class, rather than making it a list of inventory item, I'm going to make it a class of inventory item base. So in this inventory, I don't care if it specifically has a serial number, part number, manufacturer. I just care that it inherits from inventory item base. And so my program now, does that break my program? Well, no, it doesn't, because my inventory is still in inventory. I can still instantiate inventory items and ask those questions. And I can still add them to the items. It doesn't break anything. But I've made this more generic. Now let's say that I've got some other parts which are just found items. And, you know, there are these items that we have that just don't belong, you know, they don't have a serial number, they don't have a part number, they don't have a manufacturer number. Well, what I could do then is I could, you know, over here I'm going to maybe ask user type of item. Individual item, package, or found item. And then because I've got that, I have to make this a type item equals package, else if type item is a found item, then in that case, well, let's see, how could I handle that? Well, maybe I'll try to make an inventory item base. So I'll say inventory item base found item equals new and I get an error. And it says, cannot create instance of the abstract class or interface inventory item base. And that's because I tried to instantiate a base, an abstract class. So the key with abstract is if you make it abstract, you cannot implement it. You can't instantiate. So why would we want to have this inventory item base? Well, I can't inherit from it, so I'm going to make another class. And this is going to be inventory found, inventory item found. And I'm going to inherit from the base. So I'm inheriting from the base class. And so this one can be implemented because it inherits from it. And maybe this one, what we do is we say, well, we're just going to have a string called unique description, which will be where someone describes what it is in great detail, so that we can uniquely figure out what this thing is. And so now I'm going to instantiate one of those, and that one's okay. So does that make sense that an abstract class, the key with an abstract class is it cannot be instantiated. But we can inherit from it, and if we inherit from it, then what that means is that we have these properties. We have these properties, and we get to inherit those properties. But we're just making it so that we can't. But we make it so we can instantiate it because we don't want to be able to instantiate this. We just want this to be the characteristics of a standard inventory item, but you have to provide some way of identifying it. So why we want to have an abstract class is because we want to have some standardized behavior for all of our inventory items that's common to all of them, but we also don't want to deny the ability to make unique things. But sometimes we don't really want to be able to use this directly. And we don't think it's a good idea to be able to instantiate one. Because if we created this one and put it in inventory, what could happen is someone would find it and say, okay, we've got 10 of these things that got a name and description, but we have no way of telling that if these 10 things I'm looking over here are those 10 things there because there's no unique description. Nothing unique that identifies them. So we need some kind of identification. Does that kind of make sense? And realize there's a lot of different ways of doing these things, and it just depends on what you're making your program for. So a lot of times programs give you a lot of flexibility to do things in many ways. What that does, it makes it hard to learn this stuff in detail because there are so many ways you can apply it. And there's not always an exact right answer to how you apply these things. And what you're going to find is in our programs that we give you, we kind of digest that stuff for you and kind of give you, specific ways of doing things. When you make your own programs, that kind of goes away, and you figure out how you think you need to implement it. And then what will happen is over time, you kind of get into the same difficulties or problems with your choices that everyone else does, and we all end up coming towards the same solutions. And there's actually books out there that kind of called it design patterns, which kind of describe some of the common ways solutions we end up coming to. But there can be a lot of answers. So if this seems like, well, wait, there's so many ways I could do this, the answer is yes. The key with abstract is just to understand this part. When I make it abstract, I can't instantiate it. And therefore, we say that this, in a sense, is a contract. That says if you want to be an inventory item, base class type object that inherits from that, you will have these 4 items. Does that part make sense? So what we did with the list, if we look at our inventory, I changed it to inventory item base. It can take any kind of base class item. So if I go back to my program and let's see. Yeah, right now what it's saying is, hey, because I didn't do this with else, there's a possibility item doesn't exist. So what I will do is I'll say else. We're doing a loop. It's not going to pick up that I have a continuing here. Let me see. So I kind of need to put in a new. I'll just instantiate it there so that it gets rid of my little error here. I'll end up making a new one anyway. So down here, I guess I should say found item. Oh, I see what happened. I don't need that here. I need to finish this up. So I'm going to say found item dot unique description equals get string from user. And then I'm going to say item is equal to found item. And I see when I do that, wait a moment, item, I can't put found item into item. Why can't I put found item into item up here that's declared as a inventory item? I don't need to instantiate that there. Why can't this be placed into this one? Yeah, the problem is item is declared as an inventory item right now, but found item inherits from inventory item base. So it's inheriting higher up the tree than inventory item. So I really need to make inventory item an inventory item base. So I'm going to make that via the base class type. So I can make it a base class item, but then that creates another problem. Base items don't have these, or don't have all of these things. They don't have serial numbers and part numbers. So how can I fix that? Well, I'm going to use a different approach here. Rather than putting these into these unique questions into where they get instantiated this way, I'm going to change this up a little bit. I'm going to instantiate them like I did originally. I'm just going to say item is equal to new inventory package item. I'm going to say, and then I'm just going to set item in it like this. And then what I'm going to do is I'm going to get the basic stuff that's true for the base items. And then I'm going to do this. I'm going to check to see if item is a inventory item, Then I'm going to do all the inventory item stuff. Close these up. I think we've seen these right now. Now, I can't do this directly, but what I can do is something kind of tricky. What I can do is I'm going to pass item to temporarily to inventory item. And if I put parentheses around this, this will cast item to inventory item and then allow me to get access to all the attributes that belong to an inventory item. And then if I go to here, I can do the same sort of thing. Say if item is a inventory item package, I'm going to again take cast item to a inventory item I don't need that anymore to get that package requirement in. And then let's see, next one is if it's found item, so this is, is a very important word in polymorphism. So here, let me go back through what's happening here. I asked the user what kind of thing they want to create. And based on what they say, they want to create an inventory item, an inventory package, an inventory found. And I'm making my item now point to be of the type that's at the very tippy top of the hierarchy, which is this item base. So I make the kind of item they want. And I don't have to worry about setting things in here, because what I'm going to do is, here I'm setting I'm going to set the properties that are common to the inventory item base, ID, name, and description. That's what all of them will have. So I don't even need an if here because I know that they all have that. But for the other things, I've got to check the type. Is basically returns true if this object, if it's the thing that was assigned into it is actually of type inventory item. So is, I can use is to do kind of a validation check. Make sure before I do things, treat item as an inventory item, I'm going to check to make sure it is one first. If it is one, now I want to get access to serial number and part number, but I can't get access to serial number or part number just by putting, for example, item. That won't work because item is of inventory item base, and inventory item base doesn't have the things that inventory items. Doesn't have a serial number, doesn't have a part number. So to fix that, what I do is I say, you know what? I'm going to cast it as an inventory item. In fact, you can either do it this way or you can do this. item as inventory item. Now, I need to put this in parentheses first, because if I do that, it's going to try to find some property off of just inventory item. So I've got to wrap this in parentheses and say, hey, convert item to an inventory item first, then I can get access to properties. Either of these will work. So actually, the as is kind of, it makes it very readable. You know, this is very code specific. Most people know what this means, which means convert item to an inventory item. But as reads nice as well, and especially because you have as is kind of the complement to is. Is a function that returns true if the thing on the left is of the type on the right. As basically takes that thing and converts it over as that object. So it casts it to this object type, which means that then I can get access to the properties associated with that type. So these are interchangeable. Yep, that's just casting. Just like we did static cast back in C++, all you're doing is casting it, but you're putting it in parentheses so that otherwise what you have to do is you make a temporary variable. You know, you'll see a lot of people will do this. They'll say item, they'll say inventory item, item maybe is equal to inventory item. So they'll convert it here, and then they'll use this in place here. So they create a variable. That's fine. It'll probably end up being the same thing ultimately. So that's one approach to do this is, and this is all of this is called unboxing. If you do it this way, you kind of have to, because I'm going to use that variable to get access to, because this variable being an inventory item, I can get access to serial number, part number, which are unique to inventory item, but are not available to inventory item base. So this is one unboxing approach. This is unboxing approach 2 inline with parentheses. If you do it this way, basically all you're doing is just doing this and then that all in one line by just putting that operation in parentheses. Which one, the first one or the second one? No, this is not Python. This is 1280. This is C#. Okay, so several different ways of unboxing. You know, I kind of think this one looks is easy to read, is easier on the eyes than the other ones. I might start using that more. I tended to use this more, but that's kind of noisy when you're looking at it with no extra parentheses. This has less extra parentheses, and it works just as well. And it's more succinct than doing convert it to a variable, then use that variable, and then that variable gets garbage. Yeah, I'll post it for you so you can take a look at it. Maybe next time what I'll do for additional discussion when I get an opportunity for it, I'll talk about, we didn't do anything with override with this. And that's probably good because a lot of this is just in the way you declare your variables and the way you do your assignments. That's actually the polymorphism part. The override gives you some ways that you can take advantage of that polymorphism additionally. But the real polymorphism part is this part. I declare something of a base type. I have several classes which inherit from that base class type. And then I can put them all in a common list. As long as that list is of the base type, then I can put any of the derived types into that list. Or even if I make a variable of the base class type, I can assign any type of object that is from an inherited type into that base class object. And I can use, and then it brings in boxing and unboxing. When I put a child class object into a parent class variable, in order to get back access to the element in it, I have to unbox it, which means either making a variable of the child class type and casting the parent object into the child object. Realize both of these will be pointing at the same place in memory, but from the compiler's perspective, this will be treated as an inventory item. Or I can do it kind of in line like this, which I find to be kind of elegant, especially if all we're doing is we're just setting things into here and we're not doing much more with it. So I'll post this, and then hopefully that helps a little bit. Was that useful? Cool. So I'm going to post this. And that's all I have for today. Let me know if you have any other questions. And let's see. Where are we at? Yes, I'll be posting it later, Joseph.